Second session, we will talk about cleaning and tempering of wheat. We will have two speakers. So millers know that flour quality starts with proper wheat cleaning and tempering. Our first speaker in this session will be Michael ALBERS. Michael is a milling engineer, graduated by the German milling school DMSB. Michael was for a number of years a production manager in Turkey, Southeast Asia, South America. So Michael is a hands-on miller, having a change now in the training. So he's now a manager of the Buhler Training Center. The title of the presentation from Michael is Cleaning and Tempering in its Perfection. Let's listen to Michael. Welcome.
Right, thank you very well. Thank you, Martin, for the introduction. And now I'm showing you not only the part about cleaning and tempering and quality, but also profitability. So after the presentation, you will be able to look into your own mill, to check your own mill, and to see if there's anything you can make better to get more profits in the end of the year. Yeah. Why cleaning and why conditioning before we are grinding the wheat? One of the important points is for sure the hygiene of the grain, of the flour in the end. We want to protect our machines, our spouting in the flour mill. That is very important to do. And we want to remove toxic impurities. We want to improve the baking quality, and we want to improve the color. The ash, as we all know, the mineral content of the flour. So the challenge and requirements of the miller and kind of impurities, you see here the germs which got sprouted in the wheat, that will reduce our falling number. Then you see the coarse impurities like soya, like corn, like malty things inside the wheat. You will see like disease in the wheat. You will see weevils, insects, and we want to have the right amount of water, which is going to our first break. So we are producing a very well run flour mill. So wheat properties and parameters. Here I put a few numbers, a few values inside the presentation. They are clearly there's a wide range. You have mills which are working on soft flour. You will have mills which are working on hard wheat or durum mills. So the variety is quite big. But here you can see the hectoliter weight. That is your density of the wheat, which varies from 76 to 84 kilograms per hectare. The typical values, we were 1,000 kernel weight. That is a value I like a lot to use while I'm checking on the wheat quality. 28 to 45 grams. As well, the density 76 to 84 kilograms per hectoliter. That will tell you a lot about your extraction in the end of the day, how much flour you get out of your wheat. Then the moisture level from 8. My colleagues in Saudi Arabia, they might know these moisture levels, to 14%, which we got more often in Germany, while we have a lot of rain during the harvest. The ash levels from 1.4 to 2.2, very important number as well, because in the end, the 2.2% is a high ash level. And if you have a high ash level, you get also low extraction. Protein, 8 to 17, that depends on what we want to buy and what we need for our end product. And the falling number, the 200 to 500, here we can easily see if we have any problem inside the wheat with the germination, for example, with the sprouting. And impurities should be lower than 3%. I always explain this to my students coming here to my training center because our machines are also not capable to handle 8%, 10% impurities. If you have so many impurities, we have to reduce capacity. So, right. The typical values we talked before: soft, semi-hard, hard wheat, 3 different main wheat types. There we have the 1000 kernel weight. As you see, the softer the wheat, the lower becomes the quality, and the harder the wheat, the higher becomes the quality. But price-wise, everyone knows the harder the wheat, we will pay more money. Right. So coming to the actual point, the cleaning section, here you see a classic solution. The classic solution, why classic? Because we have here the separated machines. We have our separator, the destoner, and we are now looking into the cleaning section on the one hand, and on the other, in the end of this presentation, we are looking into the tempering section. So first of all, the flow balancer or a dosing unit. We want to have a consistent flow of product into our cleaning section. That is very important for the machines coming after that. We always want to have an even distribution to the screens. We don't want to have a breakdown in between that we get wheat, we don't get wheat. So for this one, we can use the flow balancer. And we have a fair accuracy, plus minus 2%. Why fair accuracy? Because we don't need to know exactly how many tons we are getting out of the silos every day, but we want to have a perfect mix of them, because a lot of you and your flour mills are using different types of wheat. And there we want to have a mix of 30 to 70%, something like this. So we have to use a flow balancer or other scales, scaling equipments. Right. It is a small space requirement. That is a nice thing to have, because in old existing flour mills, you can easily get this machine into the into your mill, into the building. And very important, the traceability and the fault recording. Traceability nowadays in terms of quality and is getting more important. So magnets, please don't forget, magnets are very simple, easy to install, but very important for us, because we don't want to have any metals later in our material, which is going to the mill, to the first break. And we don't certainly want any metal inside the flour in the end. Then coming to the separator. The separator was the first machine in the after the magnet, the first cleaning machine in the diagram. And in the separator, we are basically cleaning by sieve size. We have coarse sieves on top. As you see here, the wheat comes in. The first part of the wheat goes on the coarse sieve. Good wheat falls through. Coarse impurities are going over. And then in the end, we are going to the sand sieve. So the good wheat is going over and the fine impurities like sand is going through. Then there are a few adjustments on the machine we can do. We can change the throwing angle. That means the vibration, in which direction it goes, how strong it will be. By this, we can just change the cleaning action of the machine. Then coming to the sieve size. For the coarse sieves in wheat cleaning, we have round sieves of 7 to 9 millimeters, or slotted sieves of 5.5 to 20 millimeters.
قطره يتراوح بين 7 و9 ملم، ولدينا غربال الرمل الذي ترونه في الجزء السفلي من الشريحة، يكون خرابيشه تكون مدورة، وأيضا هناك غربال يحتوي على أشكال ثلاثية أو مثلثات. وتأكدوا إذا كنتم تستخدمون الغربال الخشن أو الغربال الخاص بالرمل، تأكدوا من أن
small the burr side is coming up, and this one needs to be on the top of the sieve, so you can misinstall sieves. And as well, look for the flow of the wheat. As here you see the holes, then you have some metal here and you have a hole again. So the wheat kernel going from left to right would always hit a hole. If you are installing it to the wrong direction, the wheat could be able to travel only here on the metal and would not fall through. So please make sure you don't have good wheat in your offals in the end. Then coming to the destoner, a very important machine in the cleaning section. Why? Because stones are basically minerals. So these ones we want to get out of the flour. We want to reduce our mineral content. And for sure, heavy materials like glass, stones, they will destroy or damage our rolls, our fluted rolls in the first break, and by this you directly reduce your extraction of the flour mill. So here are a few points to look for. You see here our destoner, the double-deck destoner. The wheat is coming in. We have a consistent airflow through the machine, so you can adjust your aspiration air. You can adjust the distribution here towards the machine. Then we have the possibility here in the end of the destoner where the stones are coming out, so the impurities, we can adjust the flap. If you lower it down, we would have a higher airspeed and you have less product coming out. If we get it higher, we have a lower airspeed and more product would come out. And why is this so important? You will see in a second. As well, we check the screen and the rubber hollow springs here on the bottom, because when they are getting old, then the machine is shaking in the wrong way and we would not have the nice vibration anymore, which we need to get the stones out. So I talked about the right setup of this side of this flap here. You can move it up, you can move it down. And this is the ideal set point for you. I want that, or you also want that in the end, the impurities coming out of the machines are stones, but as well wheat. Not too much wheat, that is clear, but we want to have a good mix of wheat, small stones, bigger stones. We don't want to see just stones. That would be a bad adjustment. And clearly, we don't want to see a lot of wheat coming out of the machine. So make sure the outlet of the machine of the impurities is a well mix. And I talked about the sieve. You want to check the sieve. I took these pictures when I'm visiting flour mills. These are common mistakes, that the wire mesh we need, the roughness of the wire mesh is missing, even you have holes in the wire mesh. This destoner wire mesh will not clean the stones out of your wheat anymore. Right, so that is how it would look like in the offals of your destoner, very well mixed between wheat and stones. Great. Then coming to the wheat kernel, we also have, let's say, we cleaned now very well the wheat. We have coarse impurities out, the fine impurities are out, heavy impurities are out, metals are out. So coming to the wheat itself and the outer layer of the wheat kernel. The outer layer of the wheat kernel has also some sand grown to it, during harvest or during growth stadium on the field, the sand got attached to it. And this one we need to get rid of. And as well, we have bacteria. So for that one, we are using a scourer. And a scourer is a great machine. It basically works on the outer skin of the wheat. We are reducing the bacteria count of we are reducing the dirt attached to the skin by rubbing it, the wheat against the rotor segments, as you see here. Then rubbing the wheat against the sieve, and as well rubbing the grain versus grain. And these three possible movements are making sure that the dust on top of the wheat is falling through the screen and into the offals, and the good wheat is coming out in the end. Make sure in this machine that you don't have any holes in your screen, because there the wheat is dropping all the time to the offals and you would lose just good quality wheat. And make sure that you also open this machine from time to time. A lot of people are just letting it run because they say it's running. But when these teeth and the teeth are not anymore there, then you are losing one of these cleaning methods. So you see the reduction of the bacteria count. We are going, let's say we have 100% in the raw wheat, then we are going through our first cleaning. We are going to reduce the bacteria count. But then we are coming to the tempering, where we are adding the water, which I will explain soon. And after the second cleaning, we, for example, with the scourer, we are reducing the bacteria count again, because adding water to wheat always gets the bacteria growing again. So that would be for the cleaning section, a few points to look for. The Sortex is another point. We can add a Sortex into the cleaning section. That is a very important machine when you are producing special flowers, or for example, for the duro millers, when we have the discolored grains, discolored germs, we want to get them out. And as you see, this kernel itself has the same size like any other type of wheat, so the previous cleaning machines wouldn't get it out. So you have to use the Sortex. As well, the ergot contamination, ergot alkaloide, very poisonous things for humans and as well animals. So contamination with this one we can get out by using a color sorter. The working principle of the Sortex is pretty simple. The wheat with the impurities is coming into this chute here. And then we have our different cameras, for example, infrared cameras, dark sorting cameras. So each impurity has a different color. And once it has a different color, you need to have a different camera to look at this color. And once the camera detects, the machine detects the impurity, it will use some compressed air to shoot out the impurity. And in the end, you have 100% clean wheat on your first break. You should have. That is our target. And then coming to the conditioning of wheat, which is very important because we can increase our profitability in the mill. And why do we do conditioning? Not only for the money, but as well for the quality of our flour. We want to mellow the endosperm. We want to increase our flour extraction. We want to reduce the flour ash content, the mineral content. We want to get the bran tough. because when the bran gets more like leather, it's easier to cut it and to clean it by using the flutes on our roller mills. And we don't want to get the bran too dry, because if it would be very dry and we cut it, then we get a lot of bran particles, which are going then to our flour, and we get more specks. As well, the flour moisture content, we want to have a consistent flour moisture content going to our customers, going to the bakery, because only then the baker knows exactly how much water he needs to add all the time without testing it all the time. Then we have different places to add the water. Here in the diagram, you can see that we have pre-dampening. That would be important for countries which having a very low wheat moisture. Then we have the first dampening, which you use in soft to semi-hard wheat mills as a normal dampening stage. And we have the second one. If you are having very hard wheats, we need more time, more dampening units to get a second dampening. And as well, in the end, you can have a first break dampening. Not many people having it, but it is possible. So tempering times, bacteria growth, don't forget that. That is why I talked about it. Water and wheat, we are not just washing the wheat, but as well we are having the time where the wheat penetrates, where the water penetrates the wheat. And you see in hard wheats, we have 24 to 36 hours, up to 48 hours of tempering time, means the water is connected to the wheat and needs a lot of time to enter. And we have our first break moisture, and that depends on the system you have, on the wheat hardness you have, then you have different B1 moistures. But it is very important to make sure that we always have a consistent first break moisture. So if 15.5, for example, is what I want in my first break, I always have 15.5 the whole day. How do we make sure that we have this consistent moisture level? Is with our system here. It's called the moisture control unit. Here we have the flow, the quantity of wheat going in, we know, and we can exactly find out what is the moisture level of the wheat. Then these informations are going to our water dosing unit. And here the system calculates how much water I need to add to get to a certain percentage in your first break. And then we have an intensive dampener where we add the water plus the wheat. We are mixing it and putting it into our silos. And here, for example, is the picture where you see the wheat. It's ASW with 9.6% initial moisture content. And you see we added the water, in this place radioactive water, 2.5%. And you can see first after 18 hours, the water got absorbed. And if you have the same type of wheat, but with a higher initial moisture, you see you have less tempering time. That is only to better understand that you don't always have to have the same tempering times. You can change them, but depending on your raw wheat quality. So the benefits out of it, right? I talked about it in the beginning, the profits, and that is what we are looking for. You see, 2 mills. Let's imagine there are 2 mills. We have a flour production here. There are systems of around 400 tons per day flour production. Then you see our target moisture on B1 would be 16%. And on the second mill, it is also 16, both the same. But mill B, let's call it, has 0.2% less moisture in the first break, and that goes now through the whole milling system until your flour. As you see, then we have in the flour moisture 13.8, 0.2% less. The flour production is then less when we use 320-day roughly flour production or running capacity of the mill per year. Then you have a difference of 310 tons per year minus in mill B. And if we take a flour price of around $400, that depends for sure on your place where you are, we are losing, mill B is losing $124,000 per year. So that's quite a lot of money and easy to get if you know what to look for, if you have a good cleaning system, and if your tempering system is always adding the right amount of water, and if you are checking your first break moisture all the time. And what in the end, I would like also to think about the cleaning section, how important it is. Here you see an ash curve, the mineral content of the flour. And you see on the bottom your extraction levels. And you see here on the left side, the ash level, the mineral content of the flour. And you can understand that the higher we go in our extraction level, that our ash level goes up. And if we would have a poorly operated mill, let's say the cleaning section is not working properly, and the moisture content, the water is not added in the right way, then you see this curve going up straight towards the end. And if you compare, you want, for example, a flour of 0.5% ash, then you check your ash curve. And in this case, it would be somewhere here. You would have an extraction of 40%. And for the other mill, the well-operated mill system, you're going here and you are having an extraction of 72%. So we are talking about a difference of 32%. And that is pure money we are talking here in the end. So cleaning and tempering wheat is an important part of our industry. And coming now to the end of the presentation, I'm open for any questions.
Thank you, Michael. Good inputs about cleaning and conditioning. We will just follow a question and answer before we open the second question, the second presentation of this session. Any Q&A? So
should be a lot. It's a very important topic.
I will start, Michael. I have my first one. You mentioned in your presentation that the cleaning of wheat shall improve the baking quality. How can we understand which baking properties shall be improved?
So in baking quality, we talk once about the color itself. The color of the flour is in direct correlation to the color of the bread. If the baker wants to have a very light white bread, we would need to have a very white flour with a good extraction. So by reducing the impurities, we reduce the specks and the ash content. And by this one, we are improving the flour quality and the baking quality in the end, the color.
Excellent, thank you. Then we have a good question from Boniface from Nigeria. What is the difference between using normal water temperature and higher water temperature in tempering? Does using higher temperature water affect the inherent property of the grain or flour?
So for sure, yes. Now we need to know what is a higher temperature and a lower temperature. I don't recommend so much to use high temperature water because we talked about the bacteria growth. We are getting by the natural how to say, once you add water to the wheat and you put it to the tempering silo, the temperature is going up by itself. And if you are now increasing the temperature from the beginning, you would get more bacteria growth. And if the water temperature would be too hot, we have protein inside the wheat and starch, so you would already start to damage your proteins and genitalize your starch, and the flour product, the flour quality would get lower in the end.
Excellent, thank you. I have a question, just a second, about the tempering system. What's your opinion on using alternative tempering machines like Fibronet, for example, to cut down the tempering time?
Yeah, Fibronet is a possibility to use. They are all basically made for this purpose. If you cut down tempering time, always make sure that you really have the right quality of your flour and the right extraction. That is, there are plenty of different ways to use it, to add water to wheat.
Okay, thank you, Michael. Then Ayodeji asks, I usually notice broken wheat kernels in the mesh of my destoner deck on Combi Cleaner. How do I rectify this?
Yeah, the broken wheat kernels, when they block your, let me see if I can. So we would be here, we would get out of the destoner, the destoner would get blocked. So you need to make sure that the separator classifier is already, that the sand sieve of the separator is not blocked. So that
أن تتأكد دائما من أن الثغرات ليست مسدودة، ثغرات الشبكة ليست مسدودة، وبالتالي عندما تمر الشوائب. Okay.
Then Doris asking, how do we know the water is well distributed? Is there any test to check for mill balance? And how much is brine moisture or moisture will be if we have 14.5 flour moisture? So 2 questions. How do we know that the water is well distributed?
How do we know that the water is well distributed is basically that you can check all the different flour streams and check there for each flour content. And if you're going to the low ash flours and they would be very dry, and in the end of your mill you would have higher moisture levels, then you would know, for example, that your tempering time would not be enough.
Okay, and if the flour moisture is 14.5, what will be the brine moisture expected?
That depends from system to system. If the bran is conveyed a lot by pneumatic air, which is very hot, then the bran moisture will be lower. So you don't have really a correlation. For sure, it shouldn't be too high. That is an important point for bran in the silos and for packing, and to not get problems with your customer.
Mm-hmm. How do we balance conditioning moisture and extraction level while giving good quality flour and the company being profitable at the same time? Balance conditioning moisture and extraction level. So on one side, we want to have a high moisture. On the other side, in extraction, we sometimes know higher moisture gives lower flour extraction. Yeah,
that's a complicated thing, I know. Sometimes if you increase your moisture level because your customer might be happy with this, but then you get troubles in your sifter system because your sieves getting blocked. Here for sure, that's a really tricky thing to do. So it's not easy to explain in a few seconds. You have to look into your sifter system then when this is the problem, for example.
Okay. Ihab is asking, what are the factors in measuring the moisture loss inside the mill? Is it the length and shortness of the milling or the degree of humidity of the surrounding air?
Oh, there are a lot of points coming into it. One important point which I check for a lot of my customers is the pneumatic system. When we are using too much air to convey the product, you are drying out the product. Don't forget, relative humidity is always relative. It depends on the temperature of the mill itself, but high temperatures are for sure bad for moisture loss in the flour. And you should try to balance your mill very well when you are grinding in your smooth rolls, that you are not grinding too much in a certain flour mill, in a certain roller mill, and other roller mills are not doing anything. So try to balance it out and try to find the spots where you're using too much energy. Most of the time you are losing a lot of moisture there.
Okay, there is another question. What is the risk with extended tempering time?
Yeah, extended tempering time, if water stays too long or the wheat stays too long, it happens that the bran dries out. And when the bran dries out and you're bringing it to your first break, you will cut the bran and it will become very fractions of it, and you will get more specks and a higher ash content in your flour.
Okay, Salim is asking, the scouring effect will make cracks on the surface of the wheat. Would it impact negatively the lasering surface of the wheat in the break passage?
No, for sure. No, for sure not. We are not really creating cracks like, for example, in corn. When we are grinding corn, we don't want cracks, but in wheat, we wouldn't have this problem, no.
Mm-hmm. Manoj is asking, what will be the impact for the final quality of flour, suppose if over-dampening the wheat?
Yeah, the impact of it's clear that we get a too high flour moisture in the end. And with a too high flour moisture, you will have mold, funguses also in your mill system itself, in the plant sifters. You have these troubles then, right? So you don't want to over-dampen your wheat, never.
Okay, Boniface is asking, what is your suggestion on percentage of water addition when tempering semi-hard wheat for whole wheat milling?
Yeah, it always comes back to the point that we are looking for our final moisture in the product. As I said here, semi-hard wheat 15.5 to 16%. But especially if you do the whole meal, in the end, the customer wants maybe only 12%. Then you don't have enough time to dry down the product, so you have to reduce then the moisture level there until you get your initial or your end flour moisture.
Often in whole meal, that's my note is also the shelf life. So
yeah,
whole meal is definitely considered lower in moisture because of better shelf life. Then Kifa is asking, do you have any data on mycotoxins reducing during first cleaning processes, especially in the scourer?
Yeah, in the scourer, mycotoxins are getting slightly reduced. We have different types of scourer systems nowadays. This scourer I showed you is basically the standard version. We can reduce a few of the mycotoxins, which we then take out later with the aspiration channel. But we also have the peeler, which is more aggressive. So we also reduce mycotoxins. But in the end, we are going here to our color sorter, the Sortex, which can easily detect mycotoxins on the shell of the wheat and takes out the rest.
Thank you. Then Ramis is asking, is too dry air a reason for reduced humidity?
Yeah, relative humidity in the air, too dry, too hot, for sure. Yes.
Okay. Salim is asking regarding hot countries, what ways do you recommend to reduce the evaporation loss?
Yeah, always check that if you have blow lines or anywhere where you are working with air, to get air cooling system for your blow lines, to get to reduce your air consumption in your pneumatic lines, in your suction lines. And we have possibilities to lower down the temperature inside the mill with the air conditioning system, which uses a lot of energy. But in the end, if it gives you the benefits, then it's possible to use that one as well.
Okay. Then Ayodhya is asking, does the impact action of scouring wheat help destroy insects in the kernels, if any?
I would say now, not really. We have an impact machine for that one, where the wheat kernel gets thrown against the wall, and if there's an insect inside, it will break open, and you would reduce that one, yes, but not in the scourer. I cannot say no, but the scourer is not made for that one.
Good. We will have in the third session also a presentation about sortex. I have a question about color sorting. I have a question. You mentioned in your flow sheet, you have indicated optionally indented separator called trieur. Now, what is your recommendation? When do you recommend a trieur or even a color sorter?
So the trieur, for example, here in this diagram, the trieur is a great machine if you have a customer who wants chicken feed, because here in the trieur you have this broken wheat and it's good chicken feed. As well, you can mix this with a destoner outlet. You have some stones inside, the chickens need that. And the sortex I would use if you want to produce a great semolina for pasta, or if you want to produce wholemeal flour, then you can reduce the contamination, because especially in wholemeal flour, you only want wheat and nothing else inside. Then I would recommend a sortex.
Okay. Now, Salim, Nodori is asking, do you recommend to use sterilator on cleaning section?
A sterilator, if you mean the impact machine where the wheat goes inside, yes, I recommend to do so.
And Salim is just asking, do you advise to install sortex in soft wheat? If yes, what will you do with the wheat rejection?
The wheat rejection, so you mean the offals, the impurities coming out, in the end you will have only impurities, which are basically impurities. So you do whatever you do with your impurities.
Good. I want to summarize what Michael said. Color sorting is used mainly in 3 applications. When you want to have a very clean flour, low ash, low specks. When you want to have a whole meal without any chaff straw in, and of course on semolina extraction. Then Christian is asking, what is your recommendation, suggestion of always clocking at the bottom point, vibrating discharge of the tempering beans, tempering beans discharging the clocking?
Yeah, okay, that depends now on why is it happening. One reason might be that it is still too dirty, so you have too many impurities. That is a reason. But you always may need to make sure that before you fill in the wheat into your tempering bins, that you have a certain amount of dry wheat inside, because once the wheat absorbs the water, it will grow, and when it grows, it will clog your pipes and everything. So clean wheat and dry wheat in the beginning, only depending on your system. Sometimes 300 kilos is enough. Sometimes you need 3 to 6 tons.
Fine. Mohan is asking, Is there any machine to be added in cleaning section to improve the shelf life of flour? We do not want to add any additives.
You don't want to add any additives and you want to improve the shelf life. So shelf life is always improved once you have no more impurities. Most of the impurities like canola, for example, canola has a high fat content and this one will reduce the shelf life of your flour. So make sure your wheat is completely clean when it goes to the first break. If not, check your impurities, look for what it is. Is it small? Is it big? Is it a different color? And then you go to the machine which should take this out and check the machine.
Okay. Ahmed is asking, if you are milling semi-soft wheat, is there a relation between B1 moisture percentage and the cleanliness of the white semolina production?
Yeah, yes, you can say so. If you want semolina production, then the coarser you want the semolina, the less tempering time you would have and the less water you would use. He said
فترة تكييف قليلة، ولكن أنت قلت أو كنت تتحدث عن القمح الشبه الطري أو شبه اللين. لا، إذا لا يمكننا أن ننتج كمية كبيرة من السيمولينا.
Checking your final moisture in the flour, that should be your target then, I guess.
Good. Is 15.5 to 60% B1 moisture in an ideal level for a clean semolina?
Depending on, it always depends on your system itself, on the mill, on your diagram, on the amount of rolls, on how you pressed your first break and how many meters you have on the first break. There are so many points that I would go and check my own production and check out after the first break, make a sieve analysis and see where you're getting the highest amount of semolina if you need so.
Okay, then what milling indices will you suggest considering when milling semi-hard wheat for pasta?
What milling? Sorry, what milling?
I can't understand also indices.
Indices.
Yeah, let's go over. Abdul Karim is asking, what's the side effect of blending different wheat varieties, soft and hard, towards the flour baking quality? Do you recommend then flour blending instead?
I personally always recommend flour blending because you can mill each type of wheat and then in the end you have different types of flour which you can then blend to your desired flour quality.
It may have an impact to water absorption, which we'll have just the next presentation. I will go a bit faster. Michael, we need to cut the time.
No more time.
Do you recommend to install humidifier on flour in order to compensate the evaporation loss?
Yeah, better check the cooling system for your air, for the blow lines, that you have cool air inside. As we know, adding water to flour, yeah, we are coming to the bakery then. So it's possible, but me personally, I don't like to use. I better cool down the air for the flour transportation.
Doris asking, in case we install Sortex, I call it now color sorter on cleaning instead of a dryer, and we have problem in the color sorter, what do you suggest?
If you have a problem in the color sorter, try to figure out what kind of problem it is. If it is a hardware problem, then get the spare parts ready, change it, and make the maintenance, regular maintenance. And if everything is not helping, then in the end, you need to get the technologist over who knows very well the machine to help you.
Is chlorinated water recommended for tempering to improve shelf life and get bleaching effect?
I'm not, no, I don't know. I cannot answer this.
I would say it's not allowed from in most of the countries, so please look at the food safety regulation. When milling semi-wheat, semi-hard wheat to flour, not semolina, for pasta, what should be the milling? Again, indices for consideration. I have definitely also not understood what is the indices. But let's go
indices
for the next. Let's come to the end. I would say most of them we have already replied. Fine. I would say that's the part of cleaning and conditioning. Thank you, Michael. Well done. So we have a next topic, which is very, very specific. We will talk about starch damage. Why we have added this topic to this cleaning and conditioning? Because also Michael mentioned cleaning and conditioning is having an impact in the flour quality. And when we talk quality, it's water absorption is one of the parameters. Now, our next speaker will be Miss HAGER ALFADL. HAGER ALFADL holds a Bachelor of Science in Biochemistry, Master of Science in Food Science and Technology. HAGER was quality control engineer in Wheata Industry Company, which is a milling company in Sudan. HAGER, are you with us?
Yes, I am.
Okay, so HAGER will talk about the effect of moisture content on damaged starch in wheat flour from Canadian and Australian. Thank you. HAGER, please.
Let me share my screen. Hello, every one of you. In my topic, I will talk about the effect of moisture content on damaged starch and the quality attribute of wheat flour. In the first, all of us know what the milling process is. Very complex process. Every step in milling process is effective the final product. We cannot avoid damaged starch that occurring during milling process. To monitoring the milling process, we need to specificate it and rapid measuring equipment to control all the milling process. To produce a quality product, knowledge and experience are required. Here we see in this picture, the damaged starch is producing in the stage of the reduction and breaking. We can control it in the conditional wheating stage. Also, we know that it's tempering. Wheat grind starch. Starch, all of us know that starch damage, that starch is representative 67 and 68 of the whole grain. Starch is very important and measured storage. It's also important in our nutrition because its properties and its affect the final product. Every damage undergo physical damage is called damaged starch. It's appear under mechanical or physical damage. This picture shows the native starch without any damage. Here we see the damaged starch in the starch granule. The damaged starch affects the water absorption. High farine-graph water absorption is indicating good baking performance. Water absorption. It's happened very quickly, about 5.5 seconds, and when the starch granule are damaged, the water can be absorbed very quickly and very well. Okay. We know also the damaged starch is very important, that we must have to optimize it. It's a very sensitive or critical point. And the optimized point, it depends on the final product we wanted to have. If we have a high damaged starch, it may lead to sticky dough, strong groove, and undesirable browning crust. To optimize the damaged starch, we can control it by tempering or adjusted the roll in the milling process. As we in my study, the objective of my study to study the influence of different level of moisture content used in the tempering of hard and semi-hard wheat on the quality of flour. Here, let me mention that I want to thank my previous company, Wheata. They are supporting me in my research. And I obtained the material and the equipment from them. I use a Canadian wheat, the hard wheat, with protein content 13.87%, temperate to 3 level, 15, 15.5, and 60. On the other hand, I use Australian wheat as a semi-hard wheat with a protein content 11.31, temperate to 14.5, 15, and 15.5. The milling process is done by Buhler milling machine, and the tempering level are measuring. Also, I measure the crude protein, wheat gluten, dry gluten, gluten index, and all the quality parameters. Also, I determine the farinograph and extensograph for the dough for dough rheological properties. For determine the damaged starch, I use SD-matic for copying. As we see, it's a iodometric method, and it's very rapidly to reduce the time. The result was obtained is damaged starch was significantly high in a Canadian hard wheat than the Australian in the same moisture content. That because the Canadian hard is a hard wheat. In the hard wheat, the starch damage is occurring more than the soft wheat. A positive correlation between damaged starch quantity and water absorption observed. When the damaged starch is increased, water absorption also increase. High water absorption degree in the Canadian wheat is more than in Australian wheat in the same tempering level. Because I say it's for the differentiate between the protein content, and in the Canadian wheat is have more damaged starch than the Australian. Also, in my study and the previous study, we observed that the damaged starch is increasing water absorption because it is increasing the crystallized zone between the starch that allows the water to entering